We're now going to take a look at applying key methods in the single class in case study ex2. In part one of this case study, we'll apply various single operators, including from callable, map, do on success, blocking get, subscribe on, ignore element, and scheduler's single to reduce, multiply, and display big fraction objects asynchronously. We'll take a look at both fully asynchronous as well as hybrid asynchronous synchronous models in our example. You can obtain all the source code for this case study at the link at the bottom of the slide below. We're now in the IntelliJ project for case study ex2, where we'll take a look at several of the methods under test. We'll start by taking a look at the ex2 class itself, which provides the main entry point into the test program. As you can see, there are a number of different methods we're going to test. In this particular part, we're going to talk about two of them: test fraction reduction async 1 and test fraction reduction async 2. Test fraction reduction async 1 will test an asynchronous big fraction reduction using an Rx Java single and a chain of operators that run in the background, in other words, entirely off the calling thread. And test fraction reduction async 2 will test an asynchronous big fraction reduction using an Rx Java single and a chain of operators that run in the background off the calling thread. However, in this case, the result will be printed in a time blocking manner by the calling thread. As you can see, there's several other methods that we'll test when we talk about part 2. When everything is registered with the async task barrier, then we go ahead and run all the tasks and then block, waiting for all the results to be finished asynchronously. And then we print out the number of tests that completed. Let's now go ahead and turn our attention to single EX, which is where all the fun really happens. We'll start by taking a look at several fields that get used in this test. We'll start out with S unreduced fraction, which is a big fraction that takes a very large numerator, which is this value, and a very large denominator, which is that value. And it goes ahead and makes an unreduced big fraction, which we'll use to reduce later in the various test methods. We also define another field called scall, which, as you can see, is going to take a big fraction that's defined with this particular value and another one which is defined with that particular value. And then we go ahead and multiply the results of those two big fractions together. That, again, will be done in the background. And then we'll also have another third field here called block time, which is the amount of time to wait for the single blocking get call to complete without having an exception thrown. So let's now go ahead and take a look at the first of our methods under test, which is test fraction reduction async 1. As is usually the case, we start out by making a string buffer that will hold the results we're going to print when we're done, and this will be printed, of course, in a background thread. We then use the from callable factor method operator to have the big fraction reduce the unreduced fraction. So we'll reduce the unreduced fraction to create a reduced big fraction. And we're going to subscribe this to run in a single background thread using the scheduler's single operator. That will then cause the from callable to run in the background. So the reduction will be done in the background. Do on success will then be called in the background. And do on success will go ahead and have a side effect of logging the big fraction. So you can see here, we go ahead and write the thread ID this is occurring in, the unreduced fraction and the reduced fraction, and we append that to the string buffer. And this, of course, do on success is an action operator, so it doesn't actually modify the values, it just has a side effect. We then connect that to the map transforming operator, which will go ahead and call the toMix string method, which will convert the reduced big fraction to a mixed string. So it's no longer an improper fraction, as it's called. And then once again, we use the do on success action operator to display the final result. And there's a helper method here called display mixed big fraction, which takes the big fraction and the string buffer. And you can see it goes ahead and it appends the thread ID along with the mixed fraction result. And then it displays the result of the string buffer after first converting it to a string. So that's what will cause things to be displayed on the output. The last method in this single chain is the ignore element method. This operator is used to return a completable that will synchronize with the async task barrier framework. So that'll indicate to the framework that all the asynchronous processing has indeed been finished. Let's now come down here and take a look at test fraction reduction async 2. This, again, creates a string buffer as usual. As before, we use the from callable factor method operator to reduce the unreduced fraction. That will take place in the background in the single background thread. As before, we use do on success to print out an intermediate result, which we then convert using the map transforming operator to a mixed string. Now, here's where things get a little different from the previous method under test we looked at. In this case, we use the timeout operator to indicate that if the current single doesn't signal a success value within half a second or 500 milliseconds, we want to have the timeout exception thrown. In this particular case, we then call blocking get, and that will block until the result has been created in the background thread and returned, or until 500 milliseconds elapse, in which case the timeout exception will be thrown. So in this particular case, I think we are safe to assume that the exception will not occur because it'll get the result back relatively quickly. If all goes well, we'll append the result to the string buffer. Then we go ahead and convert the string buffer into a string and display it using big fraction utils display. And in this case, since everything now has been done with a combination of asynchronous and synchronous calls, the synchronous part being the blocking get, we can return an empty single since all the processing has been done. So now let's go ahead and actually run the program. We're just going to take a look at the first two results that come back here. And as you can see, we call test fraction reduction async 1. These are the results that are created in the background thread. You can see that this is taking place in thread 22, and the results are being printed in thread 22. So that's all taking place in the background using the string buffer. And then you can see over here, this result actually takes place in the main thread, thread 1. And that's because we used the blocking get call with our timeout in order to wait for the background thread to finish the other parts of the computation. So the reduction is taking place in the background thread, and converting to a mixed string is taking place in the background thread, but the final result is being printed in the main thread because we used blocking get. We'll take a look at the results from the other parts of the methods under test when we do part 2 of this video.